Okay, today I asked you guys to do the Chemistry 5 review, so I just want to kind of run through some of these definitions and some of these problems. I'm not going to do every single one of them, but I'm going to kind of guide you through. So what is a mole? A mole is a value representing 6 times 10 to the 23rd particles, and that relates to a molar mass because 1 mole of any substance, let's say carbon, is equal to 6 times 10 to the 23rd particles, and in this case that's atoms of carbon, and it's also equal to 12, which is the mass from the periodic table of carbon. And 1 mole would also be equal to, if we had CO2, that would be equal to 6 times 10 to the 23rd. And in this case, this is molecules of CO2 and 44 grams of CO2. Okay? And Avogadro's number is just the idea that there are 6 times 10 to the 23rd particles in a mole, or 1 mole. The empirical formula is like when we have a substance that is CXOY, and it is the atoms of some substance, let's say in this case carbon, and how that relates to the atoms of oxygen in the lowest whole number ratio. Okay, and this also could be thought of as not just atoms of carbon to atoms of oxygen, but the idea is then we can just do the moles of carbon to the moles of oxygen. Okay. Find the molar mass of each of the following. Just a couple side notes on this. Just remember that this is O2. If I was trying to do like letter E, this would be 40 plus, we've got 2 N's, that's 28, plus 6 O's is 96. So the value for that one would be 164 grams per mole. And then I'll just run through these. This is 32, this is 101, this is 96, this is 331, or 331.8, I guess, and this one is 303.3. And those are all grams per mole. Okay, let's try some of the later ones here. All right, this question number 3 relates directly to what we were just kind of talking about. Consider the masses of various hardware below. So we have a washer, a hex nut, an anchor, and a bolt. And the mass of the washer is 1.74, and the anchor is relatively speaking 3 times heavier as our lightest thing. And so our lightest thing of all of these things is obviously the washer, and that would have a relative mass of 1. And then if this is 3 times the 174, the 1.74, that would be 5.22 grams for that. And 3.16 relates to 1.74 as 1.82. Okay, so if I divide this number by that number, that's telling me that the hex nut is 1.8 times as heavy as a washer. So instead of comparing it to everything, or to grams, we just compare it to that. And then this one would be 4.39 times as heavy as a washer. And the connection between these and the atomic masses in the periodic table is that everything was relative to hydrogen, which has a mass of 1. Okay, so those are relative masses is the idea there. And then it says, question 4, I said to skip. Go ahead and skip ahead to number 5. And it says use Avogadro's number to do the following. Show work and use labels. So again, my system, I want you to use mus. Measurement. So a number. Sorry about the writing there. A unit. So grams, liters, moles. And the S is the stuff. What is it a measurement with a unit of what? So how many atoms are in 0.0015 moles of zinc? So if we're relating atoms to moles, we should know that from our handy dandy periodic table that for every for every 65 grams of zinc, so again, here's my MUS. There are 1 mole of zinc and 6 times 10 to the 23rd atoms of zinc. Okay, so I'm using my mus, measurement unit stuff for all of these. And then grams, I don't really care about it because I'm only relating atoms and moles. So I could say that we have 1.5 times 10 to the negative third moles of Zn. And that relates to some number of atoms of zinc. So take out my handy dandy calculator and I figure out what I divided by in order to get there. And I find that 1 divided by 1.5 is going to be, I'm going to divide by a really big number. I divide by 6.66 times 10 to the second. Sorry about the writing there. So again, I'm dividing this by 6.66. Make this a little bit smaller. 6.66 times 10 to the negative second. And if I divide that, you should end up with an answer of 9.03 times 10 to the 20th times 10 to the second, positive second, sorry, not negative second, up there. So because 6 divided by 6.66 has to be a number less than 1, that's going to be 0.903 times 10 to the 21st, and then when I move it back over, it's times 10 to the 20th. I'm going to skip ahead. Let's just give you the answer to B. This is 0.352 moles of, oops, sorry. I was looking at number 4. This is 80 grams of oxygen, and part C is 1.63 times 10 to the 22nd atoms of Na. And then let's do part D together. Part D says how many atoms of chlorine are in 16.5 grams of iron 3 chloride. So we could say for every 162.3 grams of FeCl3, there is 1 mole of FeCl3 and 6 times 10 to the 23rd molecules of FeCl3. Okay, so if I wanted to figure out how many atoms, I've first got to figure out how many molecules there are. And we have 16.5 grams FeCl3. So we figure that out, and I don't really care how many moles there are, so I'm just going to cross that off and I divide by the same factor here. So let's figure out what that factor is. I divide by 9.85. So if I divide this number by 9.85, I'm going to get a number less than 1. So this will be 0.61 times 10 to the 23rd, which is 6.1 times 10 to the, I would take this out 23 spots and bring back 22. So 22nd molecules FeCl3. And let me just erase this real fast and we'll end here. So if I have, for every, make this a little bit smaller, for every 1 molecule of FeCl3, there are 3 atoms of Cl. Okay, and I got that from this idea of FeCl3. There's 1 Fe and 3 Cls that make up FeCl3. So I don't have 1 molecule. I have 6.1 times 10 to the 22nd molecules FeCl3. And so to get from this to this, I multiplied by 6.1 times 10 to the 22nd. And so 3 times 6.1 would be 18.3 times 10 to the 22nd, which if I round that out, I'm going to go out 22 and come back 23, 1.83 times 10 to the 23rd atoms of chlorine. And then let's just talk through the last one, letter E, over here. Just clear this out. Okay, and letter E said, what is the mass of 100 million atoms of gold? Well, 100 million is 100 times 10 to the 6th atoms of Au, which is gold. Okay, so I know that, and I know also that for every 197 from our periodic table grams of Au, there are 1 mole of Au and 6 times 10 to the 23rd atoms of Au. And we said that we had 100 times 10 to the 6th atoms of Au. Okay, so to get down there, I'd have to take, this is basically 10 to the 8th, so I have to divide by 6 times 10 to the 15th in order to get there, and you can figure that out yourself. So I'd have to divide this number by 6 times 10 to the 18th, so 197 divided by 6 is 32.83 times 10 to the 18th grams of Au. So I would have a very small number. So we would have we would need a very small, we would need a scale that measured all the way out to the 16th place. And so our scales, even the best ones in our room, measure out to about this place. So we don't have any scales that could actually measure out 100 million grams of gold. Okay, I hope that helps with that page.